Perfect. All right, guys. So this is section 132, the intro. And if you were in my class yesterday, I am going to reintroduce part of this and give you an alternate step for finding the y-intercept, because I had kind of misled you, and I apologize for that. But I'll try to get to that within the first 5 minutes. So if you're checking in from yesterday, you can just move along as you go through this pretty quick. All right, here we go. Now the thing is that this equation is very, very similar to the equation that we had before, to this one. Okay. The only difference between our growth and decay formula and the new one is that, look, they already found the multiplier. They've already done this work, and look what they did. They put the multiplier just as that term, okay, the base to our exponent of x. So this is exactly what we've done before. We just don't have to do those first steps where we put in the rate and deal with it as growth or decay and then simplify. So we get to this step here. The other difference is that we have a plus c out here. The plus c is just going to move the graph up and down. So you can see here in our example, the asymptote, that's our plus c, our asymptote, is a line that you can think of it almost like an airplane is coming down. You know, the airplane is coming down, it's trying not to hit the ground, and what does it do? It flies right up and never touches the ground, okay? That's what an asymptote is. It's a limit that you're approaching, but you never touch, okay? So our asymptote is c. To find the y-intercept, this is different from what I said yesterday, apologies. The y-intercept, all we're gonna do is plug in x is equal to 0, and when x is equal to 0, where are you? Here's x equal 3, 2, 1, 0. When you're at x equal to 0, you're on the y-axis. So that is the only step that changed. When we get down here, we have our steps, and with our steps, we're talking about number 1. Come on, get it all on one page. This doc cam like moves like millimeters at a time. There we go. All right, so this was a drawing I did to explain something else. Don't worry about it. But here's the thing. First, sketch your asymptote. So here, the asymptote is right here at, y is equal to 1, and it's just a horizontal line. So if I am sketching if we're doing this example here, no, let's use paper. All right, so if I'm doing my example here, and I have a problem that's y is equal to, go ahead and write this one down, example. Y is equal to 3 times 2 to the x plus 1. Okay, so let's look at our steps, and let's see if we can do this. Step 1, sketch the asymptote. So I like it because we just go right to graphing. Okay, sketch the asymptote. What is the asymptote? Show me on your fingers. What is the asymptote? Now you guys are writing something down. There we go. Nice, Ryan. Good, Nikolai. What is the asymptote? Asymptote is 1. How do I know? Because every single time, all I have to look at is the constant, and the constant is where we're going to put our asymptote. So it's just going to be, good, Charlie, got it. We're going to be right here at 1. And I'm going to go ahead and make my asymptote. This is y is equal to 1. This is my asymptote. You can just abbreviate it like that. Okay. Now, the only difference from what I taught yesterday and the correct way here is the second step is just to plug in 4 values. 0 is now on our list, and that's going to give us our y-intercept. So step 1 was sketch the asymptote. Step 2, plug in a few points. When we have x at 0, x is 3, 2, 1, 0. When x is 0, then we're going to be on the y-axis. So that's going to give us our y-intercept. Okay? So watch. I'm just going to plug these in, do them pretty quick. 3 times 2 to the 0 plus 1. What does the highlighted give us? What is 2 to the 0? It's not 0. It's the weird one. Yep. It's the weird one. Good. That is the name of it. This is the multiplier, but what I'm asking is just when you assess 2 to the 0 power, what you get is 1. Anything to the 0 is 1. 87 to the 0, 1. Negative 1,753 to the 0, 1. Don't matter. X to the 0, 1. Doesn't matter. Anything to the 0 is 1. If you didn't know that, circle it. Make a star, make a few examples so you're good when you go back to study. All right. 3 plus 1, 4. So I know that when I plug in 0 for x, I get 4. So if I'm doing my table, I'll write another one here. 0 for x, we get a 4. So 0 for x, 4 is going to be 1, 2, 3. Wait, 1, 2, 3, 4. So I know that's on my graph. Next, let's plug in 1. Y is equal to 3 times 2 to the first plus 1. 3 times 2 to the first is 2, so 3 times 2 is 6 plus 1, 7. So I plug in 1, I get 7. And these are points, right? So I already plugged in 0, 4, that's right here. Now let's plug in 1, 7. I'm just going to put it about up here, as we're going to quickly run out of room. All right, I'm just going to do one more for time. Y is equal to 3. And plugging in 3 points is approximately, you're going to be pretty close. You're going to be good. All right. 2 squared, 4. Times 3 is 12. All this is 12. 12 plus 1, 13. So when we plugged in 2, we got 13. And that's a point again. That is the point 2, 13. So all you have to do is then plug in these points. We had 7, so this one's way up here. And then once you get the points approximately right, you can make your graph. But remember that all the graphs are like airplanes trying to go as low to the ground without hitting the asymptote. So we're going to end up flying right close to the asymptote, but never hitting it. Okay, so when you write these out, draw them out, you gotta just make a curve. And if here was the asymptote, it's just going to keep getting close, but never touch it. This is actually your first intro to what you'll see in calculus. Calculus is about limits, approaching something but never getting there. Think about this. Look at your door in your room. If you went halfway to your door, and stopped there, and then go halfway to the door from where you stopped, and then wherever you stopped, go halfway to the door from wherever you'd stop, you could do that forever because you would get close, halfway. You see how you would never get there. So this idea about limits, it actually expands your mind about a lot of things having to do with like infinity, about big ideas like that. So I think it's helpful. I don't want to do too much more, actually, because you only have 5 problems. Get started getting used to this. So thumbs up, sideways down for doing these like this. I might stop the recording and do another if needed. But how do we feel? If you're on video, definitely tell me. Okay, good. Perfect. All right, let's stop. All right. So that's a nice short 8-minute video.